Hey guys, so in this video I want to talk about how we put together matrices, not actually create them, but splice two different matrices or even more than two matrices together. And this idea of splicing is called matrix concatenation, and it's actually a very easy thing to do in MATLAB. So let's look at this example. I have two matrices here, A and B, that are both one row by three columns. Well, we can put these things together, and we can do that by using a notation like this. Let's say I want to stack them in this way. So I want to do 1, 2, 3, 4, 5, 6, all in one single long row. Well, I could define a new matrix Z, and then what I can do is I can say A space B. And again, this is saying take all the matrix of A, put it inside an even bigger matrix, and then keep in the same row, because again, spaces and commas mean in the same row, and then put all of matrix B right next to it. So what this is doing is we're actually combining A and B into one large matrix. So if I hit enter, you can see that we get a Z matrix that contains all elements of A and B, and they've been spliced together or concatenated together. We can also do something like this. Maybe we don't want to stack them all in one row, but we want to stack them on top of each other. Well, we can do A semicolon B. And again, what this is doing is it's taking the A matrix and the B matrix, and it's stacking them on top of each other because we're using a semicolon. So that's saying put them on separate rows. But again, we're putting it in this larger matrix, so now we're able to combine matrices. The only thing that you guys need to be aware of is that when you're trying to splice matrices together, you can only splice together matrices that'll create another rectangularly shaped matrix. If you get some sort of irregular shape, it won't work. So I have an example of that. Let's look at C. Now, if we were trying to splice A and C together, we're not going to be able to do that because that would create some irregular shape, right? It would be a one row, but then there would be like a second element of C hanging off here. So if I tried to do something like this, where I combine A and C row-wise, it's going to complain, and that's because it would create an irregularly shaped matrix. So matrix concatenation is very useful. And one of the most useful ways I've found to use it is if you're trying to build a matrix using a for loop. So for example, if every single iteration of a for loop, you get out some sort of value and you need to store that value, well, you can always tag it on to the end of a growing matrix. So you can always, at the end of each iteration of a for loop, add on one additional element by doing something like this. So you could have your matrix, and then what you can do is you can say, take that same matrix and then add on whatever value you get at the end of an iteration of a for loop. And if you do that over and over and over, you're continuously growing this matrix by placing itself inside there, plus that new value. And so this is really useful. If you have that for loop, you can build up a bigger matrix and keep all the values you need to use for later. And I would like to point out that there's a very useful web page, again through the MathWorks documentation. And so do check it out if you guys want a little bit more information about that. But I'll see you guys in the next.